Hello class, introducing logarithms today. We're going to go ahead and start with the definition. So log base b of y is equal to x if b to the x power is equal to y. So here we're going to compare in logarithmic form to exponential form, something we're more familiar with. So it starts with log base 2 of 32 is equal to 5 for the same reason that 2, the base, to the 5th power, what it's equal to, gives us 32. So let's take a look at a couple of our examples here. Something that we know that the 0 power gives us 1 in the same way that something to the 1st power gives us the same number. These are our two special logarithm examples that is just a good thing to keep track of. So log base 5 of 1 gives us 0 because 5 to the 0 power gives us 1. And then log base 10 of 10, the same log base b of b, of course gives us 1 in the same way that 10 to the 1st power gives us 10. So now, if your base is greater than your argument, then you're going to have a negative exponent or a negative result here if you evaluate your logarithmic equation. So what we got here, log base 10 of 0.1 is equal to negative 1, because in order to go from 10 over 1 to 1/10, you have to do something to the negative power. So 10 to the negative 1 gives us that 0.1. So now we flip it the other way. If you have 1/2, log base 1/2 of 2 is equal to negative 1. Well, we know from previous lessons that we can switch sides to switch signs. And that's why 1/2 to the negative 1 power gives us 2. So this is a quick comparison between logarithmic form and exponential form. Now we're going to go ahead and evaluate logarithmic expressions. So what we've got here, to help you find the value of log base b of y, ask yourself what power of b gives you y. So I've got my first one here, log base 3 of 81. So ask 3 to what power gives you 81? And as you can see here, it's 4. 3 to the 4th power is 81. So now log base 5 of 0.04. So 0.04 is also the same as 1 over 25. So chances are the negative 2 power is what we're looking for. 5 to what power gives us this argument? Now we know. So log base 1/2 of 8 is negative 3. Again, kind of that switching sides, switching signs concept that we've been doing. And finally, log base 9 of 3 gives us 1/2. When the base is greater than the argument, then you're going to have something like this. So 9 to what power gives 3? Well, we also might remember that the square root of 9 is 3, and one other way to write a radical is with a rational exponent. All right, so we're going to go ahead and move right along here. Instead of rewriting, we're going to go ahead and solve. So, quick equation we're going to start with. Let's say we've got log base 3 of 4x plus 3 is all equal to 3. So what we know is 3 to the 3rd power is also equal to that. So we're going to go ahead and continue to evaluate and finally isolate the variable x. So 27 is 3 cubed. And now we need to go ahead and take away 3 from both sides. And then also we're going to divide by 4. So we've got 24 over 4 is equal to x, or 6 is equal to x. All right, let's do one more quick example. All right, so we've got our log. We're going to take a look at a base 5 this time. And now we've got 2x minus 5, and it's all equal to 2. So that means 5 squared will be equal what we have here, our argument in the parentheses. So 5 squared is equal to 2x minus 5. We add that to both sides to isolate x. And then we just need to divide both sides by 2. We're left with our answer, x is equal to 15. All right, that's a quick introduction on logarithms. Remember to like, comment, and subscribe.